In this video, we will practice graphing rational functions and finding the zeros, asymptotes, and holes. This is AP Precalculus topic 1.11. If you appreciate this content, please show it by hitting the like button. Problem number 1. Here is f of x. Part A. Write an equation for f of x in factored form. So let's see, f of x equals, let's factor that numerator. Let's go for binomial times a binomial. X squared will be x times x. 12 is going to factor as 3 times 4 or 2 times 6 or 1 times 12. But since inner plus outer must equal a middle of 1x, let's do 3 times 4. To make a middle of positive 1, we need an inner of negative 3x and an outer of positive 4x. Now for the denominator. The denominator is going to factor as x times x and 3 times 1. To make a middle of negative 2, we need an inner of negative 3x and an outer of positive 1. I'm going to skip to part C because it makes the other parts easier. Find any values of x where f of x has a hole. That is going to be when a factor in the denominator cancels out with a factor in the numerator. So we have a hole at x equals 3. Back to part B. Find any zeros of the function f of x. Zeros will come from any factor in the numerator that does not get canceled out. So we will have a 0 at x equals negative 4 because of the x plus 4. Part D, find any vertical asymptotes of f of x. F of x will come from any factors in the denominator that did not get canceled out. So we will have a vertical asymptote at x equals negative 1. E, find any horizontal asymptotes of f of x. Well, when the degrees are equal, the horizontal asymptote will be the ratio of the leading coefficients. So that's going to be y equals 1. Part F, find the domain of f of x. The domain will be all real numbers except for any vertical asymptotes or holes. So we have a vertical asymptote at negative 1, a hole at 3, so the domain will be negative infinity to negative 1, union negative 1 to 3, union 3 to infinity. We just have to skip over the vertical asymptote and the hole. Part G. Use a graphing calculator to help sketch the graph of f of x. Let's graph as much as we can without the graphing calculator. We know we have a vertical asymptote at x equals negative 1, so there it is. There is a hole at x equals 3. Let's find the y value using the related equation y equals x plus 4 over x plus 1. That's f of x with the hole sort of canceled out. Plugging in the 3, we get y equals 3 plus 4, so that's 7, over 3 plus 1, so that's 4. 7/4 is a little bit less than 2. So we have a hole right about here. And also we have a 0 at x equals negative 4. That means 2, 3, 4. F of x will cross the x-axis right here. Finally, we have a horizontal asymptote, y equals 1. I actually think this is enough information for us to graph the whole thing without the graphing calculator. Because of the point that we have over here in the third quadrant, I believe the graph is going to look something like this. And because of the hole in the first quadrant, I believe the graph will look something like this. Let's check the graphing calculator and see how close we got. Turn on that TI-84, hit the y equals button, and type f of x in right here. Go ahead and hit Zoom 6 for a standard 10 by 10 window. Zoom 6. Alright, and this is just what we thought. Notice that you can't actually see a hole on a graphing calculator graph. You just have to know that it's there from your analysis. Number 2, g of x. Part A is to write the equation in factored form. I am going to start on this denominator because I see there is a GCF here. So factoring out the x, that will leave behind x squared minus 9. Now let's go ahead and form the final answer. I have the x, and x squared minus 9 will factor as x plus 3 times x minus 3. Then we have the trinomial in the denominator. X squared will factor as x times x. 15 is probably going to factor as 3 times 5. Inner plus outer equals a middle of 2x. So I need negative 3x inner and a positive 5x outer to make positive 2x. What do I notice now? The factor of x minus 3 in the denominator will cancel out the x minus 3 in the numerator. That means that we have a hole at x equals 3. I'm skipping to part C. What about zeros? Zeros will come from factors in the numerator that do not cancel out. So we will have a 0 at x equals 0 because of that, and at x equals negative 3 because of this. Vertical asymptotes. Vertical asymptotes will come from factors in the denominator that do not cancel out. So we will have a vertical asymptote at x equals negative 5. Part E, find any horizontal asymptotes of g of x. When the degree of the numerator is higher than the denominator, there are no horizontal asymptotes. However, if the degree of the numerator is exactly 1 more, then there is a slant asymptote. Let's find the slant asymptote by doing long division. Set up your long division with the numerator on the inside and the denominator on the outside. I like to include placeholders for any missing terms, like there was no x squared term, so I put 0x squared. There was no ending constant, so I put a plus 0 on the end. We begin the long division process by dividing the leading terms. X to the third power divided by x squared is x. And I would line that up with its appropriate term if I were you. Then take the term that you just found and multiply it by the divisor. Do the distributive property. So x times x squared will give you x to the third power. And then x times 2x is 2x squared. X times negative 15 is negative 15x. And then you subtract. These cancel out, but 0x squared minus 2x squared is negative 2x squared. Negative 9x minus negative 15x is really negative 9x plus 15x. So that's plus 6x and then plus 0. You sort of start over now. Divide leading term by leading term. Negative 2x squared divided by x squared is negative 2. So you put a negative 2 up at the top. We really can stop here. We are not finished with the long division process, but when you get to the constant, you have found the slant asymptote, which is just going to be y equals this. Find the domain of g of x. The domain will be all real numbers except for any vertical asymptotes or holes. and we found those in parts C and D. So we just need to start from negative infinity and go towards positive infinity, skipping over this vertical asymptote and this hole. So we get negative infinity to negative 5, union negative 5 to 3, union 3 to infinity. Always use parentheses for this domain because vertical asymptotes and holes are places where g of x will be undefined, so they're to never be included, and we show that with parentheses. Number 3, a portion of the graph of the rational function r is shown above. Write an equation in factored form for r of x. We see there is a vertical asymptote at x equals 1. So that means in the denominator we find a factor of x minus 1 that does not get canceled out. It looks like we have a 0 at x equals 1/2. That would come from a factor of 2x minus 1 in the numerator that does not cancel out with anything. If you set this equal to 0 and solve, you'll see that you get 1/2. We also notice that there is a horizontal asymptote at y equals 2. This is what happens when the degree of the numerator and the denominator are the same, and then the horizontal asymptote comes from the ratio of the leading coefficients. Well, based on what we have so far, the degree is already the same. And it looks like we're not going to need these parentheses because nothing else is coming. So as is, the degrees are the same, and the leading coefficients are 2 over 1, which would give us a horizontal asymptote at y equals 2. So I feel like this does it. This is the answer. Just for fun, I checked a couple other key points. For example, we have the point 2, 3 right here. If we plug in 2 for x, do we get 3 for y? Well, let's see. If we do r at 2, that would be 2 times 2 minus 1 over 2 minus 1. That's 4 minus 1, which is 3, over 1, which is 3. So 2, 3 checks out. One more. Number 4. A portion of the graph of the rational function h is shown above. Write an equation in factored form for h of x. There is a hole at x equals 1. That means we will have a factor in the denominator of x minus 1 that cancels out with a factor in the numerator of x minus 1. The y value of the hole is negative 2. We may need that later, so let's write that down as well. There is a vertical asymptote at x equals 2. That means we will have a factor of x minus 2 in the denominator that does not cancel out. There is a 0 right here at x equals 3. That means there will be a factor in the numerator of x minus 3 that does not cancel out. Finally, there is a horizontal asymptote at y equals negative 1. This will happen when the degree of the numerator and denominator are the same, and the ratio of the leading coefficients is negative 1. Ignoring all of these constants, I can see in the numerator we have x times x, that's a degree of x squared, degree 2. And in the denominator we would have x times x, x squared, degree 2 as well. So we are all set to get a horizontal asymptote that's equal to a constant. We just need the leading coefficients to have a ratio of negative 1. So that means all we really need is a negative sign in the front that will make the negative 1. Now let's check to see if the equation that we have so far gives us the correct y value for the hole at x equals 1. We can find the y value using the related equation obtained from canceling out the factor of x minus 1 that creates the whole. So let's check this. Let's plug in x equals 1 and see if we get y equals negative 2. Y at 1 would be negative 1 minus 3 over 1 minus 2. So that is negative 2 over negative 1. Negative 2 over negative 1 is positive 2, and the negative in front makes it a negative 2. So we are getting a y value of negative 2 for the whole, and everything matches up. So this is a great equation for h of x. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.